Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly fourth question. So let us first read this question, then I would constrain and find the coding part for the same. So here in this question, ways to express an integer as sum of powers. So basically, okay, yeah. So basically, here what the question says is that given two positive integers n and x, return the number of ways n can be expressed as the sum of the xth power of unique positive integers. In other words, the number of set of unique integers n1, n2 up to nk, that is say some k integer where n equals to n1 raised to power x plus n2 raised to power x plus up to nk raised to power x. Basically, there are some unique integers which after means taking the sum first we are doing it with how I explain. Okay, so there are some unique positive integer which is mentioned here. Now the thing is that one positive integer would which would be there, we need to do the power, we need to do it power to the x plus then the second which would be there, then again we need to do power to the x, and like this if we would be doing it is means basically, it is not compulsory that here it should be 2. Here it could be 3 as well. Means any type of integer would be there. But the thing is that all these integers should be unique. And these should be with the power x, which is being given us. And it should sum up to this number, which would be given to us. And now the thing is that what exactly we are required to return is the number of possibilities which could be there. And that is what we are doing here. One is the number of possibility when we are having x as when we are having x as 2 and n equals to 10. So the number of way expressing this as the sum of powers is only 1. So that's why here we are returning 1. Then since the result can be very large, return it modulo 10 is to 9 plus 7. For example, n is equal to 160, x is equal to 3. One way to express this is n, and that n would be 3 as the power, 2 raised to power 3, 3 raised to power 3, and 5 raised to power 3. So this is how we are expressing this 160. Now comes the part as per this question. Because they have asked us to provide all the possible ways which could be there. So as there comes the part that what are the possible ways, right? So in that context, we would be required to do this question by recursion. That is checking that can we go ahead with this possible path or can we not go ahead with this possible path. So there would be something like this in this particular question. So that's why we will be going ahead with the recursion. And now comes the part that what are the constraints for this particular question. So basically constraints are pretty much low. We can go ahead with directly recursion. But the thing is that they are not that much low that if we go ahead with recursion, then it will work. That is not the case. So that's why we would be required to memorize our recursive solution as well. So, yeah. Now the next thing would be that how we are required to do this question. So here, as we require to check, as we are required to check the powers, right? And that powers would be not just simple powers, it could go up to long integer values as well, right? So we would be required to calculate our powers by our own rather than using the direct power function which is provided in C++ if we are coding in C++. And then comes the next part that how we will be going ahead with doing this question. The first part would be that we require these two things, right, as it is. And the next thing would be that we require the integer. That would these all integers which would be there, would any of the combination would work or not. That all we are required to check. So in that context, we are required to make a recurrence relation and the base case which would be there and various edge cases which could occur as per the constraint. So all these combinations we would be required to check. And then further, we are required to memorize a recursive function which we will be taking, because we can't go ahead with such a huge mm, uh, complexity as per the constraint. So let us go ahead with the coding part for the same. So here, as I already told, we would be required to memorize our function, recursive function. So that's why we are taking a 2D DP here, 2D DP here. First would be for our nums part, and the second one would be for our base part. So now here we are just initializing with -1, and then we will be calling our get function. In this get function, we are first passing that number which is there, our power which is there, and starting from the 1. So this is what we are doing here. Now, okay, now our function in which we are doing the recursive part. So here the base case is if nums becomes equal to 0, then we are required to return 1. Because when number becomes 0, then for making 0, there is just one possible way. Means then that possible way would, so that's why we are just returning 1 as the answer. And then if a num is less than 0, basically it goes to negative side, then we will be returning 0. If our base is basically greater than 300, then we will be returning 0, because in the constraints which are mentioned here, our num which is there, that is less than equal to 300. So we are required to take our base as well less than 300. So that's why if our base becomes greater than 300, then we will return 0 at that time. Now this is that thing which we usually do in our memorization part, that if that is not equals to -1, then we will be returning uh, that particular integer which would be stored here. This is that particular value. So here now comes the part, because we are required to check that what is that sum which is possible. Here sum refers to the number of ways which could be possible, right? So that only thing which we are doing here. So here we will be not taking that particular base at that point. So that's why we are calling the function again at that moment. And then whatever sum would be there till that point. So that we are doing here modulo. And why we are doing modulo? Because the number could be as much large as, because it can go up to long end. That's why. Now, this is the condition when we are taking that particular base with that power. So that we are subtracting from our number, and things would be as it is the way we are doing here. And that we are adding up to a sum and then doing modulo. And then whatever sum we got till now, that we will be assigning to our DP of num base, and that particular thing would be returned to its parent caller. Basically, the thing is, here we are just calling a recursive function again and again without taking the present which is there. But when it backtracks, then at that moment we are taking those all possibilities, and because of that only here we are calculating that what would be the possibility at that particular point if we are taking this particular element. So that is the thing here. So that's why these are the not take and take condition. And now comes the part about this function. This is that power function only. Only thing is that at every point we are multiplying with long so that it doesn't overflow. And one more thing which we need to take care is about this long num. Because the thing is that when we are subtracting from this num, at some point it could be the case that it gets overflowed towards the negative side, and because of that we are taking this long end, because when we would be calling, right, So here it will go towards the negative side, right? But when it comes here, at this point, surely it will return zero. But till means when it will be calling this function at that moment, it would have been already called the value with something uh, which is not acceptable, and that's why at that moment of time it can give us runtime error. So that's why we are required to take it as long now. So this was all about the coding part for the same. Now comes the part about the time complexity. Although we have memoized a recursive function, if it would have been recursive function, then surely it would have been exponential as per the depth and the width of our recursive tree. Although width of the recursive tree uh, would be in terms of that two only, not two, it could go beyond as well as per the with it gets increase of that taking or non-taking conditions. But when we do the memoization for the same, so because of that, whatever is the DP state which we are having, so the time complexity also get reduced as per that only. So that's why now the time complexity is simply n square and the space complexity is also n square because now we are taking this particular where we are storing these particular values and discarding all others. Discarding all others in that sense that if they are already occurred, then we will be using them. So that's fine. So yeah, this was all for this particular question. If you're still any doubt, you could comment that down. And if any other suggestion as well, that also you can comment. So this was all. Thank you.